form, CSV. One of the reasons that it's possible to develop software like this without having a huge industry behind you is the existing open source software that's out there. Mostly the system that I've put together acts as glue that connects existing components. Those existing components include the Linux operating system, non-commercial software for digitally signing things called GPG, software that's been written for controlling scanners from Linux, software that's been written for doing optical character recognition that enables us to read the candidates and contests off the ballot, image processing libraries called the Python Imaging Library. There are also open source spreadsheets and open source database. Now, one nice thing about this open source software is it's free and high quality, but another nice thing about this open source software is inherent in the name open source. People who are interested can look at every line of computer code that's involved in the entire election process or the entire independent count process. And so if anyone has questions about whether the software is doing what it's stated to do, they can check the software themselves. That's what open source means. I've modestly called my system TEVS, for Trachtenberg Election Verification System. Again, it's mostly glue that connects these existing components. And what I'd like to do is just show you what the vote viewer component of this looks like. So this is from our June 8th election. I'm just going to ask it to bring up a ballot. And what you're seeing now is an overlay of the software's opinion of who got votes from this particular ballot. And the votes are indicated with the candidate name in red, the non-votes are indicated with the candidate name in blue. I'm going to set this up so that it's just going to scan through these ballots at a rate of 1 second. We can, oops, I just turned it off. We can enlarge the ballots if you wanted to zoom in and see the detail. I'll scroll down a bit so that you can see. Let's see. I can't see it. Perhaps you can on your screens, but there's a number somewhere off in the left-hand column that shows the number of ballots that are going by. And you're going to have to take me on the tape that that number is there. The printer ink was kind of light, I suppose. So that is what the software enables. You can actually have this running just a couple of ballots behind what you're feeding into the scanner. So if you wanted to have a ballot inspection taking place and project this on the wall of an auditorium, you enable anyone who is interested in doing their own count to count and basically say, yes, I agree with this software on this ballot, this ballot, this ballot, but wait a minute, on this one it seems to have gotten that one wrong. And it's been designed to be extensible, so because it's open source, people can take it and add whatever features would make it suitable to their own environment. So let me stop this. I don't want to get too techie here, but I will show you that underneath what you were just seeing are basically a bunch of spreadsheet files. So I'm going to go into the area that has this election, and if we go to the results area, see what I can find here. Bear with me 1 second as I type. I'm just going to grab one of these files and splat it up on the screen for you to look at. This is called a CSV file. It can be imported into any spreadsheet program. And what it's basically showing you, I'll just go through the first line. The first line says that there's a file in this very long path. The file number is 1804. It's a JPEG, which is an image file. and the barcode that identified what precinct it was from is given, and then it found that there was a sheriff vote for one race, and it found that Mike Downey was running, and Mike Downey is currently the undersheriff. It's using OCR to pick this information up, and it got undersheriff with a C instead of an E. And then after that, it says the coordinates at which it picked up the information about the vote opportunity. And then there are a series of numbers that boil down to how light or dark the image was at that location. And so after the 91 and the 1711, which are coordinates, you have a 47. And what that means is on a scale of 0 to 255, this was darkened to the point where it was mostly dark. It was 47. And that's low enough to count as a vote. And so if you skip to the end of that third line, you'll see that it counted this as a vote. It's a true. The next candidate was Michael Hislop, and he had 136 intensity, which the higher the number, the lighter the area. So that was too high, he didn't get a vote, and so on. So we just build up one of these files for each ballot and merge them and can give you vote counts. And if we go here, the result of adding it all together is another spreadsheet file that gives you vote totals. And you can see that there are some small quantities. You know, there was one for a misread of Dave Paris, but there was one for Abel Maldonado, but with the O not picked up as an O, picked up as a D. But there were 5,069 for Maldonado spelled correctly, and so on. And so we're able to do an independent count in that way. I should mention, by the way, that if you have questions at any point, please feel free to jump in. So where do things stand now? I've been developing the software over several elections, and so I've now got it set up so that rather than our having to build templates for each election, we're able to have the software itself optically read information off of the ballots and build its own templates. So OCR builds the ballot layouts from the images. Excuse me. It automates the counting of somewhere between 98 and 99% of the votes, and it tells you which percent you still need to look at. So instead of having 100,000 ballots to count, you have 1,000 ballots to count by hand. It shows the ballots overlaid with the votes as determined by the software. It can show you that right at the time that the votes are being counted. It reports the ballots that you still need to manually count, and just as a service, it also builds mosaics of all the write-in votes that have been entered. We use an expensive scanner for the central count, but if you were to implement something like this at the precinct level, then you could take something like this. This is a Fujitsu 4120C2. It probably retails for about $1,000, maybe $1,500. You can get them used for $500, and this will do 30 ballots per minute. Most precincts are only going to have 500 votes maximum, 500 ballots maximum. So if you had people come in towards the closed polls and spend 15 minutes feeding ballots into a scanner attached to a laptop, you could burn a DVD at each precinct within a half hour of the closed polls. And that DVD would then serve as an additional record of the information on the ballots that have been cast. You have all sorts of chain of custody issues that come up once those ballots leave the precinct. But if you have that scan, people are going to think twice about tampering with ballots after they've left the precinct, because those ballots are still going to be there on your DVD. Coming soon, we'll be putting in more documentation. I've gradually been trying to put it in a form that will be easier for other people to extend. And I think if any of you were to take 5 minutes and think about a wish list of things to add, you could come up with them, and hopefully we'll be able to start adding some of those wish list type items. There are two main websites for the Transparency Project, humetp.org and humetp.com. There's a blog that gets posting occasionally when some things come up, Democracy Counts, blogspot.com. My company is called tevsystems.com, and my personal website is mitchtrachtenberg.com. There are a number of links at my site, mitchtrachtenberg.com, to documents I've written arguing for this and also trying to explain some of the technical technical side of this. And I would encourage you to get in touch if you have any questions, to use me as a resource, and I would love to see San Francisco implement a system even better than the one we had in Humboldt. Okay, thank you very much for your time.
Thank you.